Hello everyone and welcome back to the channel. Today we're going to take a look at evaluating this interesting integral via a method involving double integration. And this integral is from the MIT OpenCourseWare course 1802, that's Multivariable Calculus, and this is problem set 7. So we'll start by actually computing a related integral, and you'll soon see why that's related. I'm just going to do that in red actually. So that's from 1 to a e to the minus xy dy. So now if we just try to evaluate this integral normally, we get minus 1 by x e to the minus xy from 1 to a. You can try differentiating that and you can see you get this. So that then resolves to minus e to the minus ay by x. Oh, sorry, that's minus ax by x minus negative e to the minus x by x. And this then becomes, so this becomes positive, and e to the minus x minus e to the minus ax by x. And if you notice, this is the exact expression we have here. So what we can actually do is frame our original question as a double integral. So if we just rewrite that from 0 to infinity of now 1 to a e to the minus xy, and then this is dy dx. And if we just sketch this out to try and find the new bounds of integration, just like that, and so we know that we're going from 0 to infinity along the x-axis, so our region is going to look something like this. And because we're going from 1 to a on the y-axis, it's going to be something like this all the way on to infinity. And so if we want to swap our bounds, then it's actually quite simple, because we don't really need to change much. We can just go 1 to a, 0 to infinity, and e to the minus xy dx dy. And now that we have that, we can actually resolve it pretty simply, because we can go 0 to infinity of e to the minus xy, and if you know how to dx, and if you know how to resolve this using limits, so we can just first write it as an integral from 0 to b of e to the minus xy dx, which is just going to be negative 1 over y e to the minus xy from b to 0. And then if we take the limit as b goes to infinity of this expression, minus 1 by y we get e to the minus by by y minus plus 1 by y. And as b goes to infinity, this is just going to be 1 over y, because e to the minus infinity is obviously going to go to 0. And so now that we have this, we can just plug this back into our earlier one over here. And so we can write this as from 1 to a of 1 over y dy, which is of course just ln a minus ln 1, which is just ln a. And that is our answer. And so this integral, which looks pretty daunting at first, is quite resolvable if we know this critical piece of information. And so this is quite interesting, because there is an integral called the Gaussian, which is from negative infinity to infinity of e to the minus x squared dx, which is equal to root pi. And the way this is evaluated is actually pretty similar. This is quite a famous integral, and maybe I'll do it on my channel some other time, but I just wanted to look at this one and just explore how double integration can be used as a tool to solve some of these more complicated single integrals. So thank you for watching, and I hope you enjoyed this video.